Welcome to 24 Hours of Pass Summit Preview 2018. We're excited you could join us today for Brandon Leach's session, a DBA's Guide to the Proper Handling of Corruption. This 24 Hours of Pass consists of 24 consecutive live webinars delivered by expert speakers from the Pass community. The sessions will be recorded and posted online after the event. You will receive an email letting you know when the recordings are available. My name is Jason Brunhall, and I have a few introductory slides before I hand over the reins to Brandon. Go ahead, Brandon. If you require technical assistance, please type your question into the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I will read your questions aloud to the speaker. You are able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. This will pop up after the webinar ends in your web browser. Go ahead, Brandon. I'd like to take a moment to thank our presenting sponsor, Quest. The staging of 24 Hours of Pass would not be possible without their generous support, and they are the reason this event is available free of charge. If you would like to learn more about Quest and sign up for information on how they can help you, please visit the sponsors page of the 24 Hours of Pass website. Next. Pass is a global, not-for-profit association where data professionals connect, share, and learn. Joining Pass is free and gives you access to hundreds of hours of free online content, live, virtual, and in-person events, the ability to join local groups in your area, and the opportunity to attend the annual conference, Pass Summit. Pass is a great way to connect with like-minded professionals, increase your technical expertise, and grow your career. Next. This 24 Hours of Pass session is presented by Brandon Leach. Brandon is a senior DBA and Microsoft Data Platform MVP working for SurveyMonkey out of Silicon Valley. He is a frequent speaker at events like SQL Saturdays and local user groups. And go ahead and hit next, Brandon. Without further ado, here's Brandon with a DBA's Guide to the Proper Handling of Corruption. And if he wants to add anything more about himself, he is free to do so now.
All right, thank you very much, Jason. I really appreciate everyone coming out and attending this session. This is a sneak peek of what I will be presenting at Summit. So obviously in this shorter format, we can't cover absolutely everything that would be at Pass Summit. So we're going to focus on the first part. How do we monitor for corruption and make sure that we know about it as soon as possible? We're going to talk about the problem itself, what I call the DR mindset. We'll also talk about incident management and tooling available to us in SQL Server, such as CheckDB and SQL Agent Alerts. We'll also look at backups, dispel some common myths, and the importance of testing their ability to restore. So when we talk about corruption, if you haven't seen it and you're a DBA, you're going to see it at some point. It happens. It's oftentimes out of your control. Obviously, we want to do everything we can to, try to prevent it, but we can't completely do that. And it can happen pretty much anywhere in our infrastructure. So it's important that we actually have a solid plan in place for responding to it and for monitoring for it before it actually crops up. So here we see just kind of a standard physical server topology. You've got your server at the top. It's connected to switches, which are connected to the SAN controllers and the SAN disk array. Now, pretty much anywhere in this communications link for I/O, corruption can occur, right? It can occur on the server itself. It can occur in transit through any of these components. It's the more complicated, the more possibility or chance for, say, hardware to go bad or create it. There's always a reason why corruption happens. And the more components we have, the more likely we are to see it at some point, or the more opportunities there are for corruption. So let's talk about the mindset behind disaster recovery. As I mentioned, it's going to happen to you eventually. It's happened to me, unfortunately, more times than I would like to admit. And most DBAs who have been out there a while have actually run into this. One of the key tenets of the DR mindset is actively being proactive about taking steps to find it. It's also about having proper protocols in place for what to do when it strikes, incident response protocols. Another thing that tends to happen is when corruption or any major issue comes in, people tend to stop. Well, they kind of go off the handle, right? They're scared. And as DBAs, our job is to understand what our options are and present those to our stakeholders and help calm them down. We're like the EMT in their emergency. We also need to make sure that we document everything. This means policies, procedures, everything that's going to help us to make sure that we follow up, make changes to our environment to reduce the likelihood of issues down the road. It also serves as something we can go back to should we have an issue. Again, excuse me for 1 second. My apologies, I've got a bit of a cold. Incident management itself is a very key thing, right? So typically the way it works is you document who your stakeholders are, what their contact information is, and you also define escalation policies and SLAs. Now, this is critical because we need to know, how long do we guarantee it'll take to recover? Can we meet that window, right? And we need to know who are the people that we need to reach out to. Typically, in a company, you'll also have what's called an incident manager on call. Now, title might be little different for that person, but generally the incident manager on call is someone that will handle getting all the proper people in whatever sort of war room you have. They'll wake people up. They'll oftentimes be a first point of contact for people outside of the DBA group. And it may just be you, right? Hopefully it's someone who rotates and deals with incidents of all sorts, not just corruption, but maybe apps go down, etc. Any of those things should be handled by an incident manager on call. Their job is also to make sure that we do postmortems on these things. And postmortems are essentially a document that is gone over by the group, by a group of managers or team leads, etc., weekly, generally weekly, covering all the incidents. So each incident for the previous week will have a postmortem for it, and that postmortem should include things like root cause, right? What could be done differently? What was the resolution, right? This is that documentation that is going to help us to actually go further. Now, another thing that typically you'll find in incident management is incidents are tracked and reported on, right? Obviously, if we see a larger rise in our incidents, we may actually want to reevaluate our processes for dealing with them. Maybe there's something we could be doing differently, or maybe we need to tweak our change management processes. And all of these kind of suggestions and everything can come out of the reporting metrics. So let's start to get into the meat and potatoes, so to speak, of what we can do to monitor for corruption, because obviously, we need that plan in place. We need to be able to know about this stuff as soon as possible. And there are a few tools within SQL Server that we can use for this. The first is SQL Agent Alerts. These allow us to be notified when certain events happen. Maybe certain errors are triggered, or certain severity level errors are triggered. But you have to set these things up yourself. You have to. They're not automatically sitting in there by default. You have to add them and say, I want to watch for this error or that error. There are a couple that are really important to have, and I'll show you a script that will actually add all those for you and demonstrate how to add them to SQL Agent. Specifically though, if you're seeing severity 19 through 25, you really want to start looking into things, especially things like severity 23. That's pretty much corruption right there. So if we look at severity 23, that means that SQL Server doesn't really think that it can't verify the integrity of the database. It's confused about it. That's a huge red flag. Severity level 24 is something like a media failure. Maybe a disk went bad and returned some errors, and things are not good. You're probably at this point you're in an incident. However, others here in this list aren't as severe. That you want to check in on them. You want to start checking down your hardware stack. Looking for issues. They indicate a problem may be coming, right? So once you hit severity level 19, then what happens is you're now into the fatal errors, right? That means that the process was actually terminated and it's bad, right? You really want to find out why that happened. Other things may still allow the query to complete, right? But at 19 and above, it's not completing. Now, severity level 22, that means that a table or index is damaged. You've got corruption. It needs to be rebuilt, or you need to do a restore in your database. So let's go over to Management Studio here, and hopefully you can all see this pretty good. If I go up to the top here, let's go over some of these, right? So there are some alerts that are not listed by severity level. We can add both severity level or the error number itself. Things like an 825 error, read retry required. This could mean potential hardware failure. So we definitely want to know when this happens. And then we get into, as you see here, we've got severity 17. So the way you add alerts is simply by calling this system procedure sp add alert. It's in the MSDB base. We can add a severity level to monitor for, or we can do, as you saw above, an error number, whether or not that alert is enabled, and we can categorize the alert, etc. You can even have alerts kick off jobs if you want. Typically, though, what you're going to do is you're going to set it up so that SQL agent will actually go out and send an email. So let me just start up agent. Apparently, I forgot to do that. So while that starts up, we will just go down here. And if you take this script, you can install it on any box. It'll just run, and you'll see everything. So let me refresh this and see if this started up. So refresh is down here. There we go. All right. You can also add them manually just by coming in here, right-clicking, and saying New Alert. That'll do the job just fine. Let me add this Severity 17 error here. Because of the job. Job doesn't exist. So once I add that from the script, we'll come over here, we'll refresh alerts. And we will go into the properties for this. Now, in this case, we've just assigned it to severity 17, which is insufficient resources. If we scroll down, if we open this up, we can get a little more detail about what we've got going here. And so this is insufficient resources. However, it is still a non-fatal error. Additionally, we can go to the response pane here, right? And we can say execute job, or more likely notify operators, right? You may have an email address that triggers a page, and you could set up an operator to actually page someone when there's an issue. And we can define all sorts of options like working hours for those operators, right? So any server you set up, you really want to have these things on. And if I go and add a new operator here, you'll see those options, like when are they available, when are they available to be paged, etc. Sorry. All right. So we've added an alert. I'm just going to go back to the slides in a second here, and we will move on. So the next tool we have is the most important tool. And this is CheckDB. It's used to check for corruption in your databases. Say you get one of those alerts, right? You want to run CheckDB generally. You want to make sure this is going to go through and it is going to test for corruption, and it will report on anything that it finds. If you are not running this, you are going to find yourself in a very bad place at some point. Not all corruption takes the database offline immediately, right? In fact, you might not notice the corruption for a long time. So we want to make sure we run this at every available opportunity. In most companies, that's weekly. And hopefully it returns nothing, but if it does, we want to investigate. Now, occasionally out there, you will find that people talk about repairing databases with CheckDB. In most scenarios, you're going to be doing a restore, right? And there is bad advice out there recommending that people use the repair allow data loss option. And I'm telling you, don't do that unless you have absolutely no other option. If you have backups, you have another option. You have no control over what is cut, and it's really bad. So don't run repair allow data loss, please. So let's go look at CheckDB. So I've created a database here, just a cheesy customer database, and I've created a couple tables in here. And in those tables, I have introduced some corruption into one after inserting some data. Now, when I run this, we're going to do CheckDB. We're going to do all error messages, no info messages. There's a reason for that. So if I run this now, knowing that this database has corruption in it, we can see that we get some results back. Now, this gives us a lot of information. It gives us the object ID and what index on that object, as well as what partition of that index. So index ID 2 in this case is a non-clustered index on the corrupt me table. Now that table's not partitioned, so that partition ID is just, it's the entire index. Now, if I had run this, if I cut this out here and I run it with, not that one. If I cut this no info messages out, what we're gonna find is that we get a lot more info. Yeah. As you can see, we got 110 rows, right? A lot more detail, but a lot harder to go through to find issues. I mean, these are a lot of these are informational messages. Like there are 1,231 rows and 15 pages for object, syscalls. We really don't want to get an email on those unless we absolutely have to. So if I go back here, let's go back and dig into that more. So another thing that it will tell us is repair level, right? This is what it thinks it needs to, what repair options we have. In this case, it thinks we need repair allow data loss. However, I'm going to tell you that is a lie. This is a non-clustered index that is corrupted. We know that because the index ID 2 tells us it's non-clustered. The clustered index would be ID 1, and a heap would be 0. Now, a non-clustered index, we can just rebuild, right? We can rebuild it. We don't have to do a restore. We don't have to accept data loss. We can just have the system rebuild it. So let's actually do that. Now, specifically, I corrupted a specific page of this. Specifically page 368 in the primary data file. We've only got one data file in this. So in order to fix this type of corruption without a restore, what we're going to do is we are going to alter the index, right, and disable it. Now, from there, we will need to rebuild it. Now, you have to disable it before you can rebuild it. That's just how it goes. So, how did I get this index name, right? How do I know what the name of that index is? Well, if I do a select from, sys.indexes, quickly here, we'll see some columns. Now, it'll give us an object ID that's going to go back to the table, the name of the index, and the ID index of the index. So, where index ID equals 2 will just get us non-clustered indexes, or the first non-clustered index, effectively. So if I run that, that'll shorten the list significantly, but not too much. So now I'm going to select, or rather I'm going to and where object ID or object name for the object ID. And then I know the table is named corrupt me. Perfect. Oh, I have an extra where in there. That's why the syntax is off. And there we have it. We can see that the name of the index, and we can thus put this together. So let's alter our index and disable it. And let's rebuild our index. Now we've actually fixed the corruption without a restore, without any sort of repair operation from CheckDB. So if I run this again, you'll see that we don't get anything back, right? So that's good. Now, again, I'm going to remove this piece and show you what happens even without any sort of corruption issue. Again, you see now we've just got 106 rows of chaff. So we're going to skip this for now. We don't want to do repair allow data loss. So what we're going to do here is we are going to go and we're going to look at backups. Now, backups, I hate to tell you, but if you're not running CheckDB, your backups could have corruption in it, right? And you wouldn't even know it. Imagine this, you end up with having to do a restore due to a corruption issue, but your backups are corrupted for the past, say, 3 months. Imagine the impact to your business, right? If you're having to do a restore because of corruption, you want to know that your backups, or you want to have confidence that they're free of corruption. So what's the point of taking a backup if you haven't run CheckDB against it? Also, people tend to think that sand snaps are backups. They're not, right? They're not a replacement for native SQL backups. And your vendor may tell you otherwise, but they are lying. They're trying to make a sale and make you happy. The same is true of backups at the VM level, right? It's not a replacement for your SQL native backups. And clusters or availability groups, they're great. They're not a replacement. I've seen environments where people have gone and said, "Oh, we don't need backups. You know, we've got clusters, or we've got availability groups." And I'm telling you, it's not, if corruption gets into one, could potentially get into all your replicas or all your nodes, and that's a huge problem. You also can't trust backups unless you've actually restored them. If you do not restore your backups, you don't know that they'll work. Now, that doesn't mean use, verify header, or that stuff's not it. You have to actually physically restore them. So one of the things I always like to do is I like to have a DR server for testing restores. That's all it does. We test restores, and if I can get away with it, I want to be able to run CheckDB on it. But if you're running CheckDB against your restored databases, you have to actually license the server. Whereas you may not have to if you have software assurance and it's solely for testing restores. That I would recommend talking with your Microsoft rep about to verify your situation, right? Again, restore header only doesn't count. Want a system dedicated, that's all you do with it. So what we do is, before we take backups, we run CheckDB. If the backup's good, we take the backup. We then copy it over to the DR server, restore the backup, and then we run CheckDB there. Again, the reason we're doing it at both ends is because we don't want to send the backup over unless it's free of corruption. And we certainly want to verify that after it's traveled across the network to the DR site, that it will also restore free of corruption. Because again, if we go back to that kind of second slide there with the physical topology, we want to see that we know that corruption can happen anywhere in the line. So it's always important to make sure that we test this stuff as often, as hard, and as efficient as we can, because corruption is going to happen, it is going to break your environment, and it's going to be painful. Now, if we go back here, let's go and actually look at what we can do with CheckDB, right? if any of you are familiar with SP SendMail and DB Mail in general, we can actually take the results of CheckDB and we can actually email out the results of that. So if we go and say we get errors, we're using this kind of syntax just with no info messages, then we'll be able to, rely on that email, send it out. We'll get an alert, and we can start responding. We can go through our normal paging. This is great. There's another place, however, in SQL Server that it stores some information about pages pages within the database that it thinks might be an issue, and that's the suspect pages table in MSDB. So if I go from MSDB dot suspect pages right here, right now, this guy's not going to have much in it. It's got that page 368 in there because we had corruption in there. However, doesn't necessarily always mean that there is corruption. It thinks there is, right? In this case, we've already repaired the damage, but we've still got entries in here, right? So if I just came across this and saw this, I'd be running CheckDB. But since I've already done that, we can actually just delete from this table. It does not clean itself out manually, unfortunately, just so you know. So we're going to have to do that ourselves. And that's just simple. Well, we can actually just truncate it. And so when we run this, it'll clear out. But before I do that, it'll give you some information. It'll tell you what database, what file for that database, and the page ID, and the last time it thought there might be corruption in there. So obviously it's empty now. So if you're going to monitor this table and all of a sudden you see entries in here, you're going to want to clean it out. The other thing is that sometimes in, say, a database mirroring AG scenario, it's possible that a secondary replica might be used to repair a page. For example, if it's bad on one but not bad on the other, there are certain scenarios where SQL Server may pull a copy of the page that is not suspect. So just be aware of that. My apologies. This throat is killing me. So we've gone through, we've cleaned out some corruption. What do we do now? Typically, what we would do now is we would be looking further. So the corruption that happened in the database, right? We want to know why that occurred. So we're going to start looking at the lower levels, virtualization layer, whether it's VMware, Hyper-V, something else. We're also going to go through the logs at our storage level. Oftentimes I found that an issue with storage is actually the culprit. We may also, if we're finding nothing there, we may start looking at, our network infrastructure, etc. I had several years back a very unfortunate experience. I was at a SQL Saturday in Oklahoma City, and I got a call from my boss. And apparently they had decided to do a SAN migration without telling any of the DBAs. And as a result, they managed to corrupt every database across 70 servers. So we ended up scrambling. We literally had to do restores for something like 500 databases. It was nuts. So oftentimes corruption may not even be in your hands, right? It may be in your it may be other teams that cause it for you. And corruption doesn't always, as we've seen here, right? This corruption did not take down this database. It was just the non-clustered index. If it had been the clustered index, we would have had to actually do a restore because the clustered index is the table, right? It effectively is the table. So we would not have been able to just rebuild it. When you rebuild a non-clustered index, it goes back to the table, pulls the information from there, and creates the new copy. All right, so it looks like I am 3 minutes early for questions. So do we have any so far, Jason?
Let's go ahead and see if some people want to go ahead and start popping questions in. One question I answered for Anaswamy says, sometimes I get recovery pending even after restored databases with recovery. It is not coming up. What is the solution? If you want to go into that, I already sent an answer for that.
Well, if you want to, do you want to read that answer or?
Well, basically the answer is it's the tried and true. It depends.
Yeah.
There's I gave a couple of scenarios. One, it could be an environmental issue. It could be slow I/O. It could be that you have a very fragmented log file
Yep.
with many VLFs, and you just have to sit there and wait for the redo and the rewind to finish.
Yep.
So
Yeah,
there's no single straight answer for you. Sorry.
yeah, I mean, recovery pending is basically it's SQL Server has to reconcile the log with the data file, and so you're stuck until that's done. So, any other questions?
No, if you have some other stuff that you want to kind of go into, maybe go back to some of the early on scripts in your demo. I noticed,
Yeah, we can do that.
you had a script that was showing up. Keep going back, the different alerts and the severities that you had prior
Yeah.
to that.
Yeah, I'm gonna send this these scripts to Lisa, and hopefully she can include them with the slides. So, but I mean, most of these alert scripts, they're pretty simple. This particular one adds all severity 17 through 24, and also includes an 825 error, which is, as I mentioned earlier, read retry required. So in that case, it's pretty simple. You could literally just run these and the alerts would be configured. The thing is, they wouldn't actually be sent out in an email, because you need to set up operators and then go in and set the notification properties for the specific error itself.
did you have a demo script right before any of these, by chance?
No, just some notes.
Okay, because you had a query result set up there on the screen before we even got into going
Yeah,
over
what
these.
that was a
Maybe it might be good to just explain what that was.
yeah, I had DBCC results up, but we can go a little
No,
more into that.
you had error numbers and severity in the result set. I didn't catch much more than that. While you're
Really?
trying to recall that, yeah. Next question from Rob. I guess I'm not sure if it's first name last or last name first. Sorry if I got it wrong. How much performance impact is running DBCC CheckDB on production?
Well, that is going to depend on your version of SQL Server. They made a lot, if you're on 2016 and above, they made some changes that make it a lot more efficient. But in general, I assume that I just run on the assumption that running maintenance is going to consume approximately up to 30% of resources, and I plan for that when provisioning. I'd rather over provision and take maintenance into account than under provision.
Yeah.
We run DBCC CheckDB on a system doing systems doing tens of thousands of transactions a second without issue, right? So yeah, in earlier versions of SQL Server, it might take a ginormous memory grant. It might create some more issues, but generally I run with the assumption that it's going to use about 30% of system resources when it comes to performance. Always plan for maintenance, always plan for CheckDB backup, overhead, etc.
Yeah, and again, we just throw in the additional. It depends how big's your database,
Yep.
How good is your I/O. It's just
A lot of factors.
yeah. So just gonna have to have a like system and test it out. From Wen Shu, sorry if I murdered your name again. Could you use MaxDop and DBCC CheckDB? It takes a long time. Thanks.
So I don't believe I've never tried to use MaxDop on CheckDB. I mean, you could use something like Resource Governor and run it through that to try to limit its operation, but
So
not sure why you want to.
you would need to have SQL Server 2016. It's an additional option added.
Yeah.
Yeah, I would rather run Resource Governor on the memory.
Yep.
And rather than change MaxDop.
Yeah.
So. Okay, we're finally getting more questions in. Again, from Anaswamy, can I split CheckDB with check table so that I do not want to run on all tables at once?
Well, yeah, I mean, you could do it one table at a time, but I mean, CheckDB is doing more than just the tables, right? It's going over every page in the database. It's going over
well, it does check catalog and check alloc as well as the check table. So
yep. I mean, I was getting to that, but if you're going to split it out, you're going to need to do, more than just check table.
Yeah, just make sure you plan for that.
Yep.
From Matt, have you seen alternative data streams cause worker non-yielding on scheduler? And it just scrolled on me, sorry. Back. Have you seen alternative data streams cause worker non-yielding on scheduler when running CheckDB?
So non-yielding schedulers from CheckDB.
Yeah,
I've
well,
seen non-yielding schedulers, and they were related to bugs that were patched in, I think, CU6 for 2016. As for whether or not specifically related to CheckDB, not specifically from CheckDB, but I have seen it in, you know, availability group environments, etc. We actually had a nasty issue months back where that was happening to us almost every day. So is it specific to CheckDB? Probably not. But there is a patch for non-yielding schedulers.
Okay, from Frederick, what's your take on page verify checksum?
Well, always use Checksum. Always.
Yep.
Don't use torn page.
or don't use no checksum.
Yeah, don't use that either. Checksum is going to protect you a lot better than any of the other two options.
It's a must. You absolutely have to. All right.
Yeah, that's a requirement.
Mohammed, I'm going to predict that this is going to be an it depends answer. So just be prepared, Mohammed. How often should we run CheckDB on a production instance?
It does depend. My view is, I mean, how transactional is the database? You know, what's the workload like? Obviously, if you've got a really heavy workload, and it's, you know, 24 hours, you may not have the same flexibility as someone who has long maintenance windows. But to be honest, I want to run CheckDB anytime I can. I want to know as soon as possible if I've got corruption. So if that means if I can run it every day, I'm going to. Most times it's going to be every week because, you know, you take the maintenance window you can get, or if your environment is 24/7 like mine, that's really all I can get away with is running it right before we do backups. So, but yeah, it depends.
And this is the last one that's in there right now. If somebody else can get a couple more in there within the next couple of minutes, maybe we can get to them. From Rob again, when rebuilding corrupted index, can we do it online instead of disabling first?
Your index is corrupt. Anything that hits that index is going to fail because of the corruption. So it doesn't do you any good to try to do it online. The only difference is your queries are going to get a different query plan while you're rebuilding it because it's disabled. It can't be used. So they're going to recompile. You're going to get recompiles, and it's going to go out and it's going to go to the base table or to a different non-clustered index. If you leave that enabled, you access to that table for certain, or to that index is down, so it's going to break queries. They're just going to fail. So you might as well disable it.
Yeah, I would endorse that as well. I usually will disable it just so long enough so I can get the index definition. I might even go so far as just dropping it, disabling it. You know, just make sure that I have a backup of the index definition.
Yep.
All right. That brings us up to 5 to the hour. So if you want to go ahead and flip back to the slides. And we have on deck is, I'm not sure I'm pronouncing this one right either, is Dejan Sarka giving us a presentation called a sneak preview with advanced R. R is beginning to become very popular. I would probably, recommend that you attend that and get a little bit more information about R and the growing popularity. In the next slide, as we wrap things up, thanks for everybody attending. Please continue to attend the rest of these sessions that have been put on by PASS with this 24 hours here. And please also fill out the feedback that should be getting provided to you. Thanks, everybody.